In the last two sections of this chapter, these next two sections, we're going to look at what to do when we don't have a right triangle and we cannot use SOHCAHTOA. So if we don't have a right triangle, then we're going to use something called law of sines and law of cosines to solve based depending on what kind of information you're given. And I heard that you learned this in geometry last year, so this should be a review. All right, so first, let's go ahead and label these sides. So you have angles ABC, and the sides are always labeled opposite of the angle. So opposite of angle big A is side small a. Opposite of angle big B is small b. And then opposite of side angle C is side C. And so the first thing we're going to learn is how to find the area of the triangle. Now, remember, area of a triangle is always 1/2 base times height. So that's pretty easy. However, base and height have to form a right angle. So if you have a triangle like this, base is here, height has to be this one. It can't just be any side you want to choose. So in the case where you don't have a right triangle, it's kind of difficult to find the area unless they give you the height. In the case where they don't give you the height, it's going to be a little tricky. So here's what you do. So if they give you only 3 sides and some kind of angle, so you're going to remember it's always 1/2, 2 sides, and sine of the angle in between. 1/2, 2 sides, and sine, please use sine, don't use cosine, of the angle in between. So you end up using A, B, and C in the area. Okay, so keep that in mind. Now you don't have to, sometimes you're not given those 3 pieces of information. You're given something else. Then the formula could be also 1/2 BC and then sine of the angle in between. Sine of the angle in between. So this is another way to find the area of that same triangle. Triangle. And then that leaves us with the last possible option, which is 1/2 AC. So if it's AC, sine of the angle in between must be B. Okay, notice how I use capital letters for all of the angles. So just keep that in mind so you don't confuse yourself if you're writing a side or not. Okay, so another way to remember is side 1/2 of side 1, 1/2 of side 2 times sine of angle in between. All right, let's really quickly apply it. So looking at number 1, you're given 2 sides and the angle in between. That is convenient. So it says to find the area, it's just going to be 1/2 side 1, side 2, and then sine of the angle in between. Please make sure you put a degree sign when you're talking about degrees. So 1/2 times 13 times 8 times sine 85 is 51.8. And then go ahead and pause this video and do number 2. Okay, you should have gotten 13.54. All right, now moving on to another thing. So let's look at this triangle. In this triangle PQR, measurement of P is, okay, I think I wrote this wrong. I think this is R. Measurement of R is 39 degrees. Measurement of Q, this lost a Q there. Q is 32 degrees and PQ is 40 centimeters. What is RQ? What is RQ? Well, first of all, this is not a right triangle. Okay, this is not a right triangle. You cannot assume this is right triangle. Obviously, if you just take the triangle sum theorem and try to figure out angle P, you'll realize it is not 90 degrees. So you cannot use SOHCAHTOA. And so you cannot say, there's a sine of one side over the other side. That does not work. So what are you going to do? Well, we're going to learn this other thing. It's called law of sines. Law of sines is pretty easy. It just says the sine of an angle over its opposite side is the same throughout the whole triangle. So if you know the ratio of one angle to the opposite side, you can keep that ratio the same for the entire triangle. So do we have a side to its opposite angle that is known? Yes, we do, this one. So we know what that is. So sine of r over its opposite side. Let's put little r and we'll say that is sine 39 degrees over 40. Okay, now the question is, what is RQ? What is RQ? So it's trying to ask for this side. If we want to figure out that side, then we need the opposite angle. Do we have the opposite angle? Not yet. Can we find that angle? Yes, we can, just from triangle sum theorem. So if we just take 180 degrees and subtract all those angles, we figured out this is 109, and this drawing is not good. That's showing us a acute angle, but in fact it's a obtuse angle. Okay, so then we can say that this ratio of big R over little r is the same as the sine of angle P over its opposite side P, which is sine 109 over RQ. All right, sorry, this is a little messy. So the part that we really need are these two. So I'm going to set them equal to each other and we're going to solve. So sine 39 degrees over 40 is sine 109 over RQ. And all we need to do is cross multiply to solve. Please do not round as you go. The more you round, the farther your answer is from the real answer. If you're going to write down numbers as you go, please round them to at least 3, 4, or 6 digits. Right? So the more you keep, the more accurate it will be at the end. So, but if you can, just leave everything in the calculator. Do not try to round. So cross multiply. RQ sine 39 is 40 sine 109. I'm going to try to write this as much as possible in the final form before I put it in my calculator. So RQ is 40 sine 109 over sine 39. Now I'm going to put that in the calculator, but I'm going to make sure when I do, I put parentheses around that and then divide parentheses. That way I don't make a calculator error on the answer. So 40 sine 109 divided by sine 39. Okay, the answer is 60.098. Okay, so this is as accurate as an answer could be. The last thing you want to do is just kind of go back and look at your triangle and say, does my number make sense? Yes, it does. If I end up getting a number that's like 1 centimeter, then I'm going to say that my answer doesn't make any sense because that's impossible measurement to create a triangle based on everything I'm given. So then you're going to have to go back and say, what error did I make? But you always want to kind of do a sanity check. Does this look right? All right, now is time for you to practice. So triangle KLM. Measurement K is 120. Oh, I drew a acute angle again. Measurement M is 50. ML is 35. What is KL? All right, so this is a perfect law of sine setup. So go ahead and figure out the answer. Come back and check your answer. All right, side KL is 30.96. All right, go ahead and give this next one a try. Okay, this one is slightly more difficult because you would have to do an inverse sine to figure out measurement of angle T before you can use triangle sum to find S, but angle S is 23.04. All right, one more on this page. Go ahead and give this one a try. All right, and this is the angle for measurement P. Now let's go into a very interesting problem. I really like this kind of problem. You really have to think pretty hard to solve this. Let's go ahead and have you try. And I'm just gonna write down the answer. And so if you're getting really stuck on how to find the answer, you just couldn't get to the answer, then you can talk to me later and I will show you a way. But it's kind of like I think it's kind of like a brain teaser. I think eventually you can figure it out. You have to bring in some of your geometry skills to be able to find the answer. So go ahead and give this a try. A, B, C. All right, go ahead and check your answer. And I did put the calculation methods on here. Now I want to talk to you about a little bit of this. So this is kind of, if you make a mistake on this, this is probably what you did. So I've seen people over the years do something like this. Let's say that they were trying to find AD. Let's just say they're trying to find AD. Actually, AC. Let's say they're trying to find AC. Then what they would do is they would not use a triangle that only has AC in it, and they would kind of extrapolate from some other side. Actually, maybe AC is not the best example. Let's say they're trying to find AD. Then they would, if you wanted to find AD, then you have to find a triangle that includes AD. And so the logical thing to do is this one or this one. And what they would do is they will combine the angles from all over the places to create a triangle, and that will not make any sense. So for example, they're trying to find this AD here, and then they would use this angle here, and then also this angle here. That doesn't make any sense at all, but that's what they would do to find AD. So what you need to do is whatever side you want to find, you need to make sure that it actually exists within its own triangle, not whatever triangle it's stuck in, because you basically can see three triangles in this big triangle. You cannot use any part of this three triangle. It has to be its own independent triangle. So make sure you do find that triangle before you try to solve for any ratio. All right, that's it for this section.